Now we're going to take our next giant leap into the assembly language for our CPU, and that is in looking at the libraries. Now what are libraries? Well, you've seen in the previous video that I can generate a little calling function, and that calling function, in this instance here, we've seen that it just adds two numbers. So we've got the little function here which we write, that's our piece of code, and then it jumps to this subroutine called add number, and this is the subroutine here. Now we could save this subroutine in the ROM, and this would be a little subroutine that we would continually use. Now in this example we won't actually create a subroutine just to add two numbers, okay, but we will create subroutines to do other interesting things. And what we can do is we can group these subroutines together. And let's say for instance we have a subroutine that prints a dot to the screen. We have a subroutine that will draw a line, a subroutine that will draw a circle, and so on and so forth. Then all of those subroutines are of a particular type. That is, they all involve the graphics display. So if you like, we could take all of those subroutines and place them in one place in the ROM, and we could call this a little library of these subroutines. And in fact, this is called a graphics library. So that's what a library is. It's just a collection of very similar or subroutines that act in a particular manner. And we're going to have a graphics library, a string library, and what else? A graphics library, a string library, and a mathematics library. And finally, we'll have a fixed point library as well, which will allow us to deal with decimal numbers up to approximately 2 decimal places. So before we crack on, and I'll show you one full example of a library function, let's quickly talk through the function which we generated in the last video, just to make sure everyone's happy with it. And I've made the screen a little bit bigger as well so it's easier to see. So on the right we have our calling function, on the left we have our subroutine, and this is going to be similar for all of the library functions. So in this function here, what we're going to do is add two numbers. So what we do is we take the first number and we push it onto the stack. We take the second number, we push it onto the stack. We then jump to the subroutine, and the subroutine we give it a name, and we store the subroutine in the ROM. The address of the subroutine is given by the EQU add underscore num, and this is the address here in this example. So we jump over to the subroutine in the ROM, and whenever we get into the subroutine in the ROM, the first thing we do is our housekeeping. We take the values that are already in the registers and we save them somewhere in memory, and that's what the store does. And then we're ready to grab the information off of the stack which we need for the subroutine. So the first thing to come off is the return address. We need to know where we're going to go back to once we've finished the subroutine. We then pop off the value, pop off the next value, which is in this case second, goes into R0, and then the next value, which is first, which goes into R1. We add R0, R1, and then we push the result back onto the stack. We then finish off with our housekeeping. We grab all of the values that were in the registers and we put them back in, and then we jump back to the return address. So we jump back to up here, and we jump back to the line just after the jump to subroutine. So we jump to this point here, and at this point we've got the answer on the stack, so we can pop that answer off of the stack and put it into the variable called answer. So this is a position in memory, and then the program ends. And the thing about this is that the code that we write is in the RAM, okay, so it's just in a code section in the RAM. The values down here are sitting in the RAM as well, so this is the input 5 and 3 and where we store the answer. We have the address of the subroutine that we want to jump to. When we go over to the subroutine, we're going to write this subroutine and it has to have the origin, which is the position of the subroutine in the ROM. Okay, so that's the same address as this one here. And the subroutine as well has got its own local variables. So these local variables, again, are going to have to be stored somewhere in the RAM. So we have to tell it where we store it in the RAM. And that's it. That's the basic structure of our code, okay, for our libraries. Now there's one point that someone had made in a previous video, and that is that we can't use this type of return for recursive functions, and that is correct. We can't use this type of return for recursive functions, and in order to do recursive functions, the return mechanism has to be slightly different. Now there's a bit more detail there than we really require for this course, but if you go in and you're doing the Design a CPU 2 and Design a CPU 3, you'll see recursive algorithms, and you'll see the return mechanism used within those recursive algorithms. So let's look at an example here of a library function, and then after that, the next video, we will start looking at our actual libraries. Now what we have here is an actual library function which is in the ROM of our machine, and this function generates the square root of a number. So on the left is the actual subroutine, on the right is the calling function. So this is how we would actually use the function within our code. So imagine you're writing a piece of code, you need to find the square root of a number. Then what you can do is you can push the number that you want to find the square root of, for example 49. So you can push that onto the stack, and then we can jump to the subroutine. In this instance here, I've called it math_sqrt. So math_sqrt is actually this address here, 0x1130. So it jumps to that address, which is in the ROM. So it jumps over here, and all this code here is already in the ROM. And I'm not going to talk through how the code actually works, because I've got a whole load of library functions there, and this series of videos isn't about getting into details of all of the functions. It's actually about taking the functions that we have and then using them to do something interesting. Okay, we're only going through the example here just so you can see how the whole thing is put together. So it runs through, it finds the square root of the function, and this example here is exactly the same as we've seen with the kind of toy example we've seen earlier. We come in here, and at the top we do our housekeeping, we store the register values, we pop the values off, we run through the actual code, and at the end we jump to the return address here, and it jumps back up to the calling function. So it's exactly the same as we seen earlier, just a little bit more complicated. Now another thing that we want to look at here is the actual code here within the machine. So if I went to this subroutine and I went run and I assembled it, and at the bottom of the screen it actually says assembly successful. Okay, so what I could do is I could get and look at the assembled code. So if I come in here, and the assembly language programs are held in here, and the machine code is held in here. So if I get into the machine code here and I find the math_square root, and that's it there, and I open it up, you'll see that we've got this assembly language code here. So that's that subroutine all assembled. Now we have to take this and we have to load it into the location 1130. So if I get into the actual machine, if we open this up, we should see. So get into the actual machine, make it a little bit smaller, and let's go into the actual ROM. So that's the ROM here. Now this is us in the ROM, and you can see that if I go to position 1130, so this is 1130, then this code here that we see over the next 4 or 5 lines down to this point here is all of the code which we've just seen, the machine code loaded into the correct position within the ROM. And I think I'll bring this up so we can see it side by side. So you can see the first ones are 200, 0, then D80, then 200 and 0. And you can see if I go to 1130, 1130, there we go, we've got the same values. So we've got our 200, 0, D80, 200, 0, D081. So that's just this code loaded into the ROM. So that's how our library functions are going to work. Now, one thing that we have to know is that in order for it to all kind of hold together, we have to have a place where we can store all this information. And I've just stored it in an Excel spreadsheet. So let me quickly just show you that, and that'll do us for this video, okay? So this is the spreadsheet I have for the ROM. And down the left hand side in the very first column is the actual positions within memory. So this just is really a carbon copy of the ROM that you see within our Logisim. And if you look, you can see that in the next column I've got the different libraries. So I've got a BIOS, fixed point library, graphics library, mathematics library, I've got a string library, I've got some reserved space and unused space. So if we were to have a look in here, you can see right away within the BIOS, I've only got two really things in the BIOS here right now, and this is a read string and a print string. And you can see that this is the code for it here. So this same code is loaded into the ROM within the CPU, within the computer. So if I head down to the mathematics library, you can see here, these are all of the mathematics functions which are already in the ROM. And the one we were interested in was the square root. So here's the square root here. So all of this code here is the square root code. And we use up all of this memory here. So we don't ever want to go in and change this. So we don't want to get into the ROM and delete this off and then put some other value in. We want to maintain that, okay? So it's a functioning piece of code. It's all been tested and works. So we want to maintain it and make sure that we keep it. So we want to actually have somewhere that we have a record of actually producing it. So this is where we generate that record. Now we have the other side here, which is the RAM. So this is another sheet which covers the RAM. Now in the RAM, if I went into data filter, you can see again it's a copy of the RAM setup that we have within our machine. And in this column here, you can see I've got it in terms of code, we've got data, input, output, we've got the stack, we've got traps and variables. So we've got different positions here in order to hold the different values that we require for our subroutines. So that's where we hold that information. Now there's one other thing which I actually have yet to produce. And part of doing this course would be part of the production of this, and that is that we mentioned whenever we generate the code for our subroutines that we have to know what values we're going to push onto the stack and in what order, and we want to know what values we expect back from our subroutine, and we need to know the positions within memory for our subroutine. So all of that has to be generated, and I'm going to generate that detail within possibly a Word document. So I'll generate that at some point over the next couple of weeks, so that's available to us. But for now, we've got a list of everything that we need here, and we can go in and we can start looking at the library functions. So that's enough for this video. It's been quite a long one, longer than I expected. So let's crack on, and this is the getting to the nitty gritty and the interesting stuff of employing our library functions. Goodbye.